Well, we have another question here, question 7. Question 7.1 says that determine f prime of x from the first principle if f of x equals to x squared minus 5. So I'm going to write the question over here. 7.1, we're looking for f prime of x, okay, from the first principle. And then f of x is given by x squared minus 5. Now, how can we do that? I prefer to write the formula first of getting the derivative from the first principle, okay? So it's like the limit, not the limit, but f prime of x from the first principle is given by the limit of f of x plus h, okay, minus f of x all over h, and then h approaches 0. So now, this is how I prefer to do it. I am going first to work out f of x plus h, okay? So in this case, it simply means that instead of x, I am going to substitute the value of x plus h, okay? So we do know that f of x is x squared minus 5. So I am going to write x plus h instead of x there, okay? So it was supposed to be x squared minus 5, so I write x plus h here in place instead of x because we're working out f of x plus h. Now, I prefer to extend this, so this will be x plus h times x plus h minus 5, okay? Now over here, we will going to do x times x times h, and h times x times h. And then this will be equal to x squared, x times x means x squared, x plus h means xh, and then h times x is still xh, okay, and then h times h means h squared minus 5. Now we can combine like terms. We can notice that we have like x plus h here, so we can combine this, the like terms. So this will be x squared plus 2xh plus h squared minus 5. So this is f of x plus h. I call it like function number 1. Okay. Now we do know also that f of x was just x squared minus 5. I prefer to write it like this. This was given, okay, I call it function 2. Now, when I look at my formula here, we do f of x plus h minus f of x. So let's minus the two functions. So I'm gonna minus these two functions here. So over here, okay, this minus sign, I prefer to write it next to the scalar minus 5. So when we're like x squared minus x squared, we can complete here by zeros, okay? The empty places we can complete by zeros. So plus 0 and then plus 0 if you want. So now we can do over here x squared minus x squared. And then over here, this will make just x squared minus x will make 0 because this will be simplified, that makes 0. And then we have like 2xh plus 0 is just 2xh plus h squared, and then negative 5 minus 5, this also 0. So the difference between f of x plus h minus f of x is just equal to 2x plus h squared. So now I want to move my board this way. Okay, you notice that so far we did work out the numerator of this limit. Okay, f of x plus h minus f of x. Here it is. Okay, now going to do this way. We're going to introduce the limit now. If I put the limit both sides, okay, it's gonna be like I put the limit here, h approaching 0, and then this will be equal to limit of h also approaching 0. Actually, let me write. If I introduce limits here, I have like f of x plus, no, f of x plus h, okay, minus f of x, and that's equal to limits over here also, h approaching 0 of 2x plus h, this part here, 2x plus h. So of 2x plus h squared. No, 2xh. I meant 2xh plus h squared. Then this means like now over all over h, okay, over h. Now we can notice that over here, this fraction, we have like h at the numerator and h at the denominator. So over here we can simplify. We can write like limits of h approaching 0, okay? And then we can take h as a common factor because h is over here in this term, 2x plus h and then plus h squared. Okay, I can take h as a common factor. So it's gonna be like 2x plus h squared all over h, okay? Then we can just simplify h here, h and h there, and then we have left with the limit, okay, of 2x plus h, only one h, not h square anymore. Oh mon Dieu, j'ai foutu ici, hein. Je dois recommencer. Well, we have another question here. The question says that determine f prime of x from the first principle if f of x equal to x squared minus 5. Now I am going to write the question here, question 7.1. So we are looking for f prime of x. Okay, this is the unknown. If f of x equal to x squared minus 5. Now we're going to solve this, as the question says, from the first principle. So the first principle implies that we're going to use this formula, okay? F derivative, the derivative of the function will be equal to the limit, okay, of f of x plus h, okay, minus f of x all over h, and then h approaching 0. Now I am going to work out f of x plus h first. So I'm going to do like f of x. Let me just write it like f of x plus h. It means where I see x, I'm going to substitute by x plus h. So this will be like, instead of me writing x squared, it's like x squared minus 5. Instead of writing x squared, I would have substituted by x plus h here. And now let's simplify this by expanding this. This is like x plus h times x plus h minus 5. I've seen students working out this like by doing working out this to say this is x squared plus h squared. Yeah, it's a common mistake, but avoid doing that. It's we must times x plus h by x plus h as I just did here in this line. So let's expand this then. This will be x times x, and then x times h, and then h times x, and then h times h. Okay, so this will be equal to h squared. Okay, x times x, x squared, and then x times h, xh, h times x, xh, and then h times h makes h squared minus 5. Now, is there any like term here in the equation? We can see that the terms that starts with x squared is only 1. So we have like x plus h here, x plus h there. So we can take these two. This will be equal to x squared plus 2xh plus h squared minus 5. Okay, and then this is the simplest form. We cannot simplify further. Okay, so this is our f of x plus h. So we can call this like equation or function 1. Now, this one, we can call this one function. Let me move a little bit closer there. Then it is given also that f of x, okay, f of x is given by f of x is given by x squared minus 5. I prefer to write it like that. And then this is like equation or function number 2. Now we can do function 2 minus function 1, or function 1 minus function 2. I mean, why am I saying that? Because I'm just working out the numerator of this fraction here, f of x plus h minus f of x. So this is f of x plus h, extended form, minus f of x, x squared minus 5. Okay, it's better to write the terms of the same variables. Okay, one's like x squared under x squared, this x squared under this x squared, and this the negative 5, which is a constant under the constant. Now we can do like x squared minus x squared, that's 0, cancel out, and then we can also see that negative 5 minus 5, okay, that makes 0, because negative 5, it makes negative 5 plus 5, minus you make plus, so negative 5 plus 5 is 0. Now we have left with what? 2x. We can complete the empty places here by zeros, okay? We can complete by zeros. So now this will become 2xh. 2xh plus 0 is just 2xh. And then h squared plus 0 is still h squared. This is the difference between the two functions f of x plus h minus f of x. Now we got the numerator of this function. Then the next thing is we notice that there is a common common factor between these two terms. Okay, you notice here between this term and this other term, they both have h. So we can take h as a common factor. If I take h as a common factor, I will have 2x plus h. So that's the difference between the two functions here, 2x plus h. Now let's move the board like this. We're going to work it out. Now we have like f of x plus h minus f of x is now equal to h, open bracket, to x plus h. Okay, this is the numerator of this fraction. Now when we divide this by h, okay, we divide by h because it's over h here. Okay, it's over h there. I will also divide by h there, and then we can just simplify the h scorn. Now I'm going to place in the limits, then the limits of the function here. This limit, the limit approaching 0, both sides. So if I put the limits on the left and on the right, so we have like the limit h approaching 0, the limit of f of x plus h minus f of x all over h equal to the limit h approaching 0 of what? 2x plus h there. Now, this limit, what does it mean? It means limit approach, when they say the limit h approaching 0, it means we're going to substitute h by 0, okay? So this will be equal to 2x plus 0. In this case, I'm not going to put the limit anymore, okay? When we sum in the value of h by 0, we don't need to put the limit, to place the limit. And then this is equal to, that's the final answer. It is equal to 2x. That's this, whatever you see here, it's just this is the derivative of the function, because that's f prime of x from the first principle. Okay, because f prime of x just the limit of this. So we have the limit of this, that's f prime of x. Now, the following question is question 7.2. Yeah, the question says that determine the derivative of g of x, and then g of x is given by 5x squared minus 2x over x to the power of 3. Okay, I want to move my board this way. Okay, I'm gonna write the question over here, 7.2. Okay, we want to find the derivative of g of x, and then g of x is given by 5x squared minus x minus 2x over x to the power of 3. Okay. Now, to work out the derivative of these type of functions, it is important to use some law of exponents to transform the function before differentiate it. So, in this situation, for instance, I'll start by simplifying this function. I'll simplify this and that. So, this will be like g of x will be okay. Maybe let's first. That was the question. So I'm gonna write here g of x will be like, it's like 5x squared minus 2x over x cubed. Okay, so I prefer to simplify this function before solving it. It will become like okay, it will become like g of x equal to 5x squared minus 2 over x squared. So far, I did not find a derivative yet, just transforming the function. Okay, and then I can continue. I can write it like 5x squared minus 2 over x squared. I prefer to use the law of exponents. So this is going to be like 2x to the power of negative 2. Why? Because one of the law of exponents says like a over, no, it's just like 1 over a to the m. Okay, this is equal to a to the negative m. So then 2 over x squared will be 2x to the negative 2. Now I can apply now I can differentiate the function. Okay, so I'll say g prime of x then will be like 5x squared minus 2x squared derivative. Okay, so the derivative is given by, okay, if you have like a x to the power of n derivative, okay, this will be like a times, I prefer to start with n times a times x to the power of n minus 1. Now, over here, we're going to work out 5x squared derivative minus 2x squared derivative. Now, applying the formula wrote in red there, this will be like 2, okay, times 5 times x to the power of 2 minus 1, and then minus, okay, I forgot to put the negative sign there, it's negative 2, minus negative 2, okay, times 2 times x to the power of -2 minus 1. Now this will become like 2 times 5 is just 10. So write 10 times x to the power of 1. I don't need to write the power of 1. Just gonna say 10x, okay? Or let's just write like that. And then negative and negative I will make plus. 2 times 2 is 4, and then x to the power of -3. So this can be written as 10x, because x to the power of 1 is just x, and then plus 4x to the -3. We can bring back the -3 at the denominator, okay, according the same law I wrote here. You remember those laws are useful from left to right as well as from right to left. So from right to left, this will be 4 over x to the power of 3. This is g prime derivative. And then the following equation will be question 7.3. All right, here 7.3. The question says that given h of x equal to ax squared, okay, x is greater than 0, determine the value of a if it is given that h minus 1 of 8 equal to h prime of 4. No, yeah, h prime of 4. All right, I want to move. Let's read the question over again. It is given that h of x is equal to ax squared, okay, and x is positive. X greater than 0 means that x is positive. Now determine the value of a if it is given that h minus 1 of 8 is equal to h prime of 4. Now I'm going to move on about this way. You can just write this formula like that because of space. Now I'm going to write it's question 7.3. It is said that h of x equal to ax squared, and the conditions provided that h is positive, okay, and then this also said that we're looking for the value of a, okay, if h minus 1 of 8 equal to h prime of 4. All right. Now let's solve this separately, okay? Because we have like h of x equal to ax squared, okay? We can work out h minus 1. H minus 1 simply means the inverse of the function h, okay? So h minus 1 will be what? Remember that h of x is just the function, okay? So it's like y equal to it's a function. So it might be like y equal to ax squared. Okay, that's h of x. Now, h minus 1 is the inverse. Okay, it means it is where we switch the variables x with y. So I'm gonna call y x, and then I'm gonna call x y. So it's like x is equal to a y squared. Now I am going to make y subject of the formula. Okay, so it's like a y squared equal to x. So if I need to find the value of y, I first divide both sides by a to get rid of the a there, and then I have like y squared equal to I have like y squared. So I'll be like y squared equal to x over a. Okay, so if I need to find the value of y, I can just square root both sides. I'll square root here and then square root there, and then this will generate what? Y equal to square root of, okay, x over a, right? Not exactly. Remember, it must always generate like it is a plus minus here, but we already know that x here is positive. So just want to leave it like x square root of x over a. Okay. that's the value of y minus 1. This is y minus, I mean h minus 1. So h minus 1, the inverse is x, y equal to x square root of x over a. I call it like equation number 1. Now move. Let's also work out h prime of hx. So right here, h prime of x will then be what? We already know that h squared, h of x is ax squared. Okay, so h prime is like according to the formula in red over here, ax to the power of n. The derivative is just a times x to the power of n minus 1. Okay, so this means it's gonna be like 2 exponent down 2 times a times x to the power of 2 minus 1. Okay, to the power of 2 minus 1, and then this will be what? This will be 2ax. Now, because it is h prime of 4, it means wherever we have x, we're going to substitute by the value 4. Sub 4 there, sub 4 there. So h prime of 4 will be then 8a. So this is like function 2. Now, in the question says that h minus 1 of 8, okay? H minus 1 of h, okay? Now let's work it out also. I call this 1, but I didn't substitute here. So h minus 1 of 8 will be what? Y equal to square root of 8 over a. So that was equation or function 1. Now, because we set the two equal, so h negative 1 of 8 equal to h prime of 4, we will set the two equal here. We're gonna do that now. Equation 1 equal to equation 2. Okay, so this will be like square root. So it'll be like square root of 8 over a equal to 8a. Now we're going to find the value of a. How can we do that? First of all, we're going to get rid of the radical sign. Okay, how can I do that? If I raise both sides to the power of 2. Okay, whatever I do on the left, I must also do on the right to keep my equality the same, because I know the power of 2 would cancel the square root, and then we have left with 8 over a equal to 64a squared. Okay, so we can solve this by cross multiplication, because 64 a squared here has a denominator of 1. There. Let me just move my board like this, and then split it like this. This will be like a times 64a makes 64a cubed. Okay, because we do this a here times 64a squared, and then we're going to do 8 times 1 here. So this will be equal to 8 times 1, 8 times 1, which is just 8. Now, if I need to find the value of a, I will divide now here by 64 and divide it by 64 also. And then I will have left with a to the power of 3 equal to 8 over 64. Then this means that a cubed equals to 8 over 64 is 1 over 8. Okay, and now a cubed equal 1 over 8. If I need to find the value of a, I'll just cube root here and then cube root there, because again the cube root will cancel the power of 3, and then this will make what? A equal to square root of a half. Oh, not square root of a half, but not square root of a half, actually a half, because maybe I should write like this before even okay, this is just like okay, let's do this way. Before putting the cubed root, so this will be a cubed equal to 1 over 8 can be written in terms of its prime factor. In terms of prime factor, 8 is 2 to the power 3. Okay, and then this is the same as to write a cubed equal to 1 over 2 to the power, because 1 can be also to any exponent. So okay, I prefer to write here power of 3. Now there's a law that says a to the power of m over a to the power of n. This is, excuse me, a to the power of m over b to the power of m. So we can just, because exponents are same, we can just write a over b to the power of m. So this is the case. Okay, we can just write a to the power of 3 equal to 1 over 2 to the power of 3. Now in this situation, we can just cube root both sides, a cube root here, a cube root there, and then the cube roots we cancel the power 3, cube root cancel here, and then we have like a equal to a half. So that was the value of a. Thank you.